You know, most of us learned that calculus was invented sometime in the 17th century. But what if that whole story is missing a huge chapter, one that actually starts 300 years earlier? Today, we're digging into the real and much, much older story of calculus.
So let me ask you, who invented calculus? What names immediately pop into your head? For just about everyone, it's a really short list.
And yep, for most of us, these are the two names that come to mind: Isaac Newton and Gottfried Leibniz. These two titans of the 17th century, their simultaneous discovery, and that really bitter feud over who got there first, it's one of the most famous stories in the entire history of science.
But what if I told you that the core ideas of calculus, we're talking complete with rigorous proofs, were already written down centuries before Newton and Leibniz were even born? Well, this is where the story we think we know takes a really fascinating turn. This much earlier origin story was brought into the light largely thanks to the incredible work of the late Professor P.P. de Vaugran, and his unique background gave him, well, the perfect lens to uncover this hidden chapter of mathematics.
So, Professor Divakaran spent most of his life as a particle physicist, working on quantum field theory, super complex stuff. It was only after he retired that he dove headfirst into history. But his deep background in mathematical physics gave him this huge advantage. He could look at these ancient texts and recognize just how incredibly sophisticated they were, maybe in a way a pure historian might have missed. His research zeroed in on this remarkable group, the Kerala School of Mathematics. It was founded by a truly brilliant mathematician named Madhava, and this school just flourished for 3 whole centuries. It became a real hotbed of intellectual activity down in southern India.
Okay, this timeline really puts it all into perspective, doesn't it? Madhavas sets up his school around 1340. The key text that documents their version of calculus gets written in the 1520s. And it's not until the 1670s, that's well over a century later, that Newton and Leibniz even enter the picture. I mean, the time gap is just staggering.
And just to put a really fine point on it, the main text, the one detailing the core ideas of calculus, with proofs, was written more than 200 years before Newton and Leibniz published their work. Just let that sink in for a second. So, what exactly did the Kerala School figure out? Well, they arrived at the same fundamental ideas as Newton and Leibniz, but, and this is the cool part, for a completely different reason and by tackling a totally different problem. See, Newton was obsessed with physics, right? Understanding motion, gravity, how the velocity of an object changes over time. But the mathematicians in Kerala, they were driven by astronomy. Their big goal was to accurately calculate the length of an arc of a circle, which they needed to predict the movement of the planets. 2 different problems, but both require a new kind of math that can handle things that are constantly changing. And here's the core technique they came up with. To find the length of a curve, they imagined breaking it down into an infinite number of teeny tiny little pieces. Each piece is so small, you can basically treat it like a straight line. Then you just add them all up. This whole concept, summing an infinite series of infinitesimally small parts, that is the very essence of integral calculus. And using this method, wow, they made some incredible breakthroughs. They were the very first to find the infinite series for sine, cosine, and arctangent. These are series that are absolutely fundamental to math today, and they're usually named after the European mathematicians who rediscovered them centuries later. Okay, so this brings up a huge question, right? Just how similar were these two versions of calculus? And maybe more importantly, could the ideas from India have somehow, some way influenced the work being done over in Europe? So, when you look at the core technique, the approach was basically the same. Both used the idea of limits and infinite series. The big difference was the scope. The Kerala school was intensely focused on the trigonometric functions they needed for astronomy, whereas Newton and Leibniz developed a much more general calculus that you could apply to pretty much any function. This is it. This is the million-dollar question. When you have ideas this similar, separated by centuries and entire continents, you have to wonder, was there a connection? After a ton of research, and I mean, he read all 7 volumes of Newton's private papers, Professor Divakaran came to a conclusion. The answer is no. There is just no evidence that Newton or Leibniz ever saw or even heard of these Indian texts. It just seems to be one of history's most stunning examples of independent discovery. So, if this school was so incredibly advanced, why did its discoveries just fade away? Why wasn't this monumental achievement a standard part of our history books this whole time? Well, it turns out there are a few key reasons. First, the most important book, the Yuktapasa, was written in the local language of Malayalam. Now, most scholars at the time, and definitely later Western historians, worked in Sanskrit, so this text was effectively locked away. Second, the arrival of Portuguese colonists in the region led to a lot of conflict and instability, which really hurt the school. And finally, as the school itself faded, so did that unique mathematical culture that had nurtured all these amazing ideas. And what's really important is that Professor Divakaran didn't see this as some kind of injustice or a big conspiracy. He argued that it was really just complex historical forces, not malice, that were the reason this incredible knowledge was lost to the wider world for so long. So, what does rediscovering the Kerala School really mean for us today? It's way more than just a historical fun fact. It fundamentally changes how we should think about the history of innovation itself. For one, it rightfully puts Madhava, the school's founder, up there with the greatest mathematicians in history. He was, without a doubt, a giant of the medieval era, and it's time he got his due. It also completely forces us to adopt a much more global view of scientific progress. You know, these incredible intellectual leaps weren't just confined to Renaissance Europe. They were happening all over the world, driven by different cultures that had different problems they needed to solve. Ultimately, this story of the Kerala School is just this powerful reminder to question those simple narratives we're so often told. History is messy, it's complicated, and it is filled with these incredible stories of parallel innovation and, sadly, lost knowledge. And that, of course, leaves us with one last thought-provoking question. If the origins of something as fundamental as calculus could be hidden for 500 years, what other incredible stories are still buried in history, just waiting for the right person to come along and uncover them?